In this video, we're going to highlight new features related to one-way shear graphical reporting in Adapt Builder 2020. And we can see in this model we have areas of the slab that are two-way slabs, one-way slabs, and also beams. The new one-way shear reporting is specific to beams and one-way slabs. It's important for the user to set the criteria of the design strips that we want to produce these graphical reporting options for as beam or one-way slab. In this example, we have, for example, beam lines. I'll go ahead and look at this beam along this line, and if I double click on that design cut, you can see the setting for design is labeled as beam. The new graphical reporting options are part of the result display settings. I'll go ahead and open that. This is informally referred to as the result browser or red eyeglasses in the software. We'll go ahead and open that option. We're going to select a strength combination or the strength envelope. So I can select, for example, strength, dead, and live. And in this option for analysis, once we design the strips, we'll have an option here for design sections. So let's go ahead and design the strips to gather those graphical results. We'll go back to floor design. We've already produced our design cuts and our design strips, and we'll design the sections. After the design of the sections is complete, we can come back to analysis, and we have this design sections options here shown in the result display settings. Now I'm going to go ahead and just collapse everything. I'll come back to design section options, and you'll notice this option now for one-way shear. We'll select the button there to expand that, and then we're going to go through each of these different options. One thing we can do, rather than look at the entire slab with the different beams, I could isolate beams. So let's isolate this beam here in the middle. There's a 3-span condition. I'll just go ahead and select those design strips or design strip, and also if I wanted to show the beams underneath, I could select those beams and select the control to select the group. So we'll do that. I'll right click and say show that selection, and this gives us a little more clarity as to what we're actually looking at. So first of all, if we wanted to look at the design actions, the VU along these different spans for these beams, we can go up here to actions. I can select shear, and this is going to produce a graphical view of the shear requirements for strength, dead, and live. And we can see the shear requirements along each of the design cuts shown there. That's actually going to be used when we look at the VU versus VVC ratio down below. It's also used to calculate the reinforcement both for required and provided reinforcement. So coming down here to the one-way shear design options for the shear stress check, if I select that, this is going to give us a color indication of the design sections that don't apply, that need reinforcement, that don't need reinforcement, and also that may exceed the maximum allowable shear capacity per code. And we can see that the blue regions are locations where we need reinforcement. Green is okay, we don't need any reinforcement there. And the pink region that's dashed is a region that exceeds code. So that might be a region we pay particular attention to when evaluating these beams. The next option is the concrete shear strength option, VVC. This gives us the code required calculation of the concrete shear capacity for one-way members. In this case, this is based on ACI 318. If I go to the design code, this is version 14 of that design code. So selecting this option will produce the capacities on each design cut. And we can see those capacities are listed here. And again, this is only for one beam that I've isolated. I could show the entire slab with all the beams in the slab at one time in either the X or the Y direction. So this graphical view is just a little bit cleaner to look at than the entire slab here. The next option is VU over VVC. So this gives us an indication of that ratio that's used in some cases to generate or to produce a need for minimum reinforcement for shear for a beam member or one-way slab member. So we'll go ahead now and show this option. Okay, and we can again see the ratios along each design cut. If you want more accuracy or more digits to be produced for these ratios, we can always go to settings, and I can increase the number of significant digits for the different values. Also, the legend here will show the max and min. The max is based on everything. It's not only based on what's being shown, it's based on every beam or one-way slab design cut in the slab. So in this case, we don't have a maximum of 7 on this particular support line. We do have a maximum of 5.4, so that's obviously really high. Under floor design, if we went and we turned off this 1, 2, 3, we can show max and min on the support line. So this allows us to show the minimum value and the maximum value just on that support line using these two buttons here. Coming back over to analysis, the next option is the area of steel required versus what is provided. Now in this case, the shear reinforcement is specified on a design strip basis. So if I select this design strip and I go over here to the design criteria, this is being set as a beam, and the number of stirrup legs is set as 2. So in previous versions this was a global setting. In this version this is a local setting to each support line. The bar size that we're using is actually shown under criteria, and this is under rebar, size, and material. So for beam criteria, I can select the preferred stirrup size for that type of a criteria selection. And so the area of steel required is based on the user's setting, or it's based here just on calculation. The reinforcement will be based on whatever you have set as the size and also the number of legs that you've chosen to provide for this member. Okay, and this shows us the amount of reinforcement. So if we scroll back up, we can see we need 0.7 square inches per inches square per foot. So this is either per foot or per meter depending on what unit system you're in. And again, this is the required area of shear reinforcement. If I look at the provided area of shear reinforcement, this is what the program calculates that you need over that incremental distance. So this is similar to longitudinal reinforcement, where you may by calculation need a specific value, but by placement of actual reinforcement that value may change because the amount of reinforcement is some fraction of the value that's required. So this shows us the area of steel provided, and then finally we have the shear stirrups. Now one thing we can do to clean this view up also is under floor design, I can turn off the display of the design cuts. This gives us a much cleaner view than having those intersect the beam. I could also go to shear stirrups, and again this will show us the reinforcement layout. It gives us the quantity of stirrups, the spacing of the stirrups, and the distance in relation to the columns or the supports or ends of the beams for these stirrups. And this is laid out, it's flattened. This is obviously a top view of the beam, and you can see the different groupings here for these stirrups. And again, you can modify the text size if there's overlap in the output. And I want to compare this to the previous ways that you were able to get one-way shear reinforcement in this program. Previous ways are still there. This is just a newer, more condensed, efficient way to produce the results. So first way, that's probably the most, the easiest way to produce this reinforcement is after we've designed the sections, and I'm actually going to calculate the rebar here so we can get the longitudinal and the shear reinforcement. This shows us the longitudinal for everything, but I'll go ahead and design or look at just this one design strip. I can use this option to produce an elevation of that strip, and if I produce that elevation, it's going to show me essentially the same set of information just in an elevation view. And you can see the reinforcement shown in this view as well. So that's also available to the user. If you select this X and delete, that will delete that image. You could also go back and go to Builder Sum. This is a sub-module, and in the summary report we give some indication of the shear reinforcement there. You can see there's the number 5 bars, 2 legs. This is a little more summarized. It's harder to tell exactly where the stirrups start and stop, but you can at least see the density of the stirrups here. And then lastly, if we go to reports for this design strip, if I select just that strip and I go to reports, design strip, rebar. This rebar report, and I'll just produce this for one combination. Let's call it strength. I'll deselect all and reselect that. And this is going to report not only the flexural reinforcement, but also the area of steel for shear on a section basis. So all of these design cuts will report what reinforcement is needed at each particular location and each design cut. And that's going to be produced as an RTF report out of Microsoft Word. And we can see here, this lists the section numbers, the longitudinal reinforcement, and if we scroll down here, we should be able to see a few of the, this is all probably two-way slab here, but if we scroll down, we can pick up the shear reinforcement as well where that is present, and that will be in these outer table blocks in the reinforcement tables. So this report is a little more difficult because you have to map the section and the reinforcement back to the graphical plan here in the graphical interface. If you have any questions about these changes, please contact us at adaptsupport@risa.com.